prep course on determining horizontal and vertical components. This would be a review for you, but I think that we'll go through the details anyway, so that if you need that extra help. The idea behind finding horizontal and vertical components is that every vector can be broken into two parts. And as I wrote in italics here, if you asked your math teacher, they'd say it can be broken into an infinite number of parts, meaning that you might want to find the component of a vector that's in the 20 degrees north of east direction or something like that. But we'll leave that unpractical. It's unpractical. We do horizontal and vertical because it's very practical in physics. I think in math you might not do them at all. I'm not sure. But we do care about it. So a horizontal component reflects how much of a vector is sideways, and a vertical is up and down. Of course, that would depend on how you're drawing it. And you could also do the same thing in 3 dimensions, by the way. Notice we always talk, east, west, north, south, but we do, if you did projectile motion, you do up, down, and sideways. But for example, we would never do east, west as one direction, north, south as another direction, up, down in the same question. And of course you can. There's no reason why you can't. It's the exact same problem, but it's in a 3rd dimension, and that you do talk about in calculus class. Anyway, so this is what I'm saying. Most often, X is what I'll call the east-west, Y is the north-south, but sometimes in dealing projectile motion or something, the vertical, or the Y, would be the up-down, and the horizontal would just represent side to side, and whether that's east-south or northwest, it doesn't matter. Okay, so let's just do an example then. So if you had this vector here, in this case it's a displacement vector, that 40 meters, 70 degrees east of south. So just as I draw it, here's the south, so I draw 70 degrees away from that. Okay, and so there's the vector, and you know how to draw them. The first thing you do is you enclose this. Okay, and usually what you do is you say, if I know the 70, I'm going to enclose the 70-degree angle. But theoretically, you know that you got 20 right there. So you could enclose it here. You could go right across and down like that, horizontal and vertical vectors. And the answer, by the way, is the exact same. dx is still dx and dy is still dy, regardless of which way you do it. Okay? And that's just related to the cosine sign, because you choose, for x, you'd use cos if you did it right here, and it'd be cos of 20. And if you did x over here, it would be sine of 70. And it's the sine of 70 is the same as cos of 20. But anyway, back to the problem. Enclose the right angle, okay? And when you do that, in this case I enclosed the 70. The part that went down is my vertical or y component. The part that comes across is dx, okay? And if I want to find what they are, and I recognize that you probably know how to do this, but let's just do it anyway. First, remember what the basic trig rules are. That if I was looking to find out how to find this opposite side, I would use the sine rule and say that's hypotenuse, which in the case of a vector is the magnitude of your main vector times sine of the angle, and adjacent is hypotenuse times cos of the angle. So depending, if this is my dx, then it's going to be the hypotenuse times cos of theta. In the question that we were looking at, I would say, since the x component is opposite the angle that we have, which is 70, we use sine, because sine and opposite go together, and adjacent and cosine to go together. So y component, the y vector, is actually touching the 70, so that's what I mean by adjacent, so you use cos. Okay, and that's what it is. And I didn't define a positive direction. I guess we'll assume that south and east are positive, so these are positive vectors. Okay, and then obviously you could put that in your calculator and get a number. As you work through your assignments, I want to remind you again that when I do them all in one step. The answer is almost always just one step. There's no rounding until the very, very end. So that's why, if you round early in a problem, for example, by doing this and rounding it, and then you carry that through on 3 more steps or something, that means your answer is getting further and further away from mine. Less and less accurate, truthfully, but I wouldn't hold that against you for marks. But when you compare your mark to mine, or your answer to mine, the difference, if it's within sort of the same, it's kind of close but not quite, that's why, okay, is I don't round. because my computer doesn't force me to. Okay, anyways, let's try this one on your own. So please, pause the video. It should take you a couple seconds to figure out the horizontal and vertical components, and I'll put the answer. So pause now, but I'm going to flip to the answer. Okay. So if we call north and east positive, then my x must be negative, okay, because it's moving away, it's moving to the west. And it's 20 times cosine because it's touching. X is touching the 50, so it's cosine. Y is not touching the 50, so it's sine. So hopefully you got the same thing as I did. And that's the end of this little video on finding horizontal and vertical components.